In one of my former videos titled The Door System Explained, I had only explained a few details regarding wiring. This video will cover the main parts of the wiring system in town, as well as explain the basic information needed to learn it. In this video, we will go over definitions of wiring, standard requirements of wiring, and types of wires. Before we continue, let's start off with some important things and terms. A wire is a part that is used to create a kind of interactable that can or cannot influence another interactable. An interactable consists of at least one wire and at least one part. Wires are created with the Texture Tool tab within your building tools. To create a wire, select a part, then add a texture to it. All wires require a -500 or 500 value as a transparency. The digit on the left will change the type of wire depending on the number, and the digit on the right can change the variant or speed of the wire. For some wires, an audio ID from the marketplace can be pasted into the image ID to play a sound when the wire is activated. To create an interactable, you must select all your wires and parts by holding Shift while clicking on the parts. Then press Shift and G to group it. Once your wires and parts are grouped, you need to use the command !WC to turn on the wires. If you ever want to ungroup a wire, you must select the group and press Shift and U. You can also select specific grouped parts by pressing Shift and T and clicking on the part you want to select. There are currently 10 types of wires within town. Some types of wires can have different variants, such as a Type 5 force gate, which has 6 variants, or Type 10 logic gates, which have 7 variants. These variants are capable of changing what a wire does when interacted with. We will now go over types of wires. Starting off with a Type 1 receiver, this wire is used to help move parts by representing the starting position of a part. You are able to change the speed of the part that moves to this wire by changing the digit on the right. Increasing the value will decrease the speed, and decreasing the value will increase the speed. After the Type 1 receiver, we have a Type 2 receiver. This wire is also used to help move parts by representing the ending position of a part. You are able to change the speed it takes for the part to move to the receiver's position the same way you would with a Type 1 receiver. Type 1 and Type 2 receivers work together to move parts within builds by representing a starting position with a Type 1 receiver and an ending position with a Type 2 receiver. After those receivers, we have a Type 3 transmitter. This transmitter is capable of sending signals to another receiver known as a Type 4 receiver. However, we'll get to that one next. A Type 3 transmitter can only send a signal to a Type 4 receiver if the transmitter is part of an interaction that already consists of at least a Type 1 receiver and Type 2 receiver. Once the interaction is interacted with, it will then send a signal to the Type 4 receiver. After that, we have a Type 4 receiver. This Type 4 receiver is responsible for receiving the signal that a Type 3 transmitter sends to it. Once the signal has been received, it will trigger the interaction that it is a part of to activate. An important thing to know about a Type 3 transmitter and Type 4 receiver is that the Type 3 transmitter will send a signal to the Type 4 receiver that is the same color as it. This means you are able to have multiple Type 3 and Type 4 wires. The transmitter receiver pairs just need to be the same color. Here's an example of a Type 3 transmitter sending a signal to a Type 4 receiver. Once the interaction is activated, the Type 3 transmitter signals to the Type 4 receiver to activate this interaction. After that, we have a Type 5 force signal. This force signal is responsible for changing the type of signal the Type 3 transmitter sends to the Type 4 receiver when activated. A Type 5 receiver can send 6 different signals. The types of signals are listed here. A positive signal means that it will activate the other interaction, while a negative signal means that it will deactivate the other interaction. An example of a positive interaction is opening a door, while a negative interaction is closing a door. In order to use a force signal, your Type 5 force gate wire needs to be part of an interaction that already has a Type 1, 2, 3, or 4 wires. Here's an example of a force gate sending an only positive signal. As you can see, the door opens. However, you cannot close it by pressing the same button again, because the force gate makes the button only send a positive signal, which is the signal that's used to open the door. Here's an example of a force gate sending an only negative signal. The door closes, however, you cannot use the same button to open the door again, because the button can only send a negative signal. All the rest of the Type 5 variants are pretty much just swapped, such as sending a negative signal first and then a positive signal. Next up, we have a Type 6 shootable gate. This gate is very simple. All it really does is allow you to activate an interaction by shooting it. As shown here, your Type 6 shootable gate would need to be part of an interaction that already consists of at least a Type 1 and Type 2 receiver. Shooting the shootable gate will then activate your interaction. You can change the sound that plays when shot by adding the audio ID from the Roblox Creator Marketplace into the Image ID section here. After that, we have a Type 7 touch gate. This touch gate simply allows you to activate an interaction by touching the touch gate. In order to use your touch gate, it needs to be part of an interaction that at least has a Type 1 and Type 2 receiver. This touch gate has 3 different variants and are all listed here. A Type 1 variant will activate an interaction upon touch of the part. However, the interaction won't activate again until the same part is touched another time. A Type 2 variant will activate an interaction once touched, then untouched. Once again, in order to activate the interaction again, the same must be done, well, once again. Finally, a Type 3 variant will activate the interaction for as long as the part is touched. Once the part is no longer touched, it will no longer activate the interaction. After the touch gates, we have a Type 8 monitor. In town, you are able to create viewable cameras. The Type 8 monitor simply allows you to view through your cameras. In order to use your Type 8 monitor, it needs to be grouped and wired to at least a single part. This brings us to our ninth wire, the camera. A Type 9 camera is literally used as a camera to view regions in your build. In order to use your cameras, it needs to be grouped and wired to at least one other part. Similarly to the Type 3 and Type 4 wire, the Type 8 monitor and Type 9 camera are color-coded, which means that the Type 8 monitor will provide a visual for a Type 9 camera that has the same color as it. This also means you are able to have multiple cameras. Last but not least, we have logic gates. Logic gates basically change the requirements of a possible interaction. This wire has 7 variants. Logic gates are used to create more complex kinds of interactions. They are usually part of interactions that already have a Type 1, 2, and multiple Type 4 wires, as shown here. Starting off with variant 1, we have the OR gate. What this variant basically does is allow more than a single interaction to trigger this interaction. Here we have 2 different interactions with different color Type 3 transmitters. The OR gate variant basically allows either of these interactions to be used to trigger this interaction. This variant is called OR because you can use either this interaction or this interaction. In summary, the OR gate allows you to have multiple trigger interactions. Our next variant is the AND gate, which is variant number 2. This gate increases the requirement for an interaction to occur. For example, we have 2 trigger interactions to activate this interaction with the AND gate. We cannot use a single one of these interactions to activate it because it requires both of these interactions to be activated in order to activate the AND gate interaction. In summary, An AND gate forces a requirement that requires multiple interactions to be activated in order to activate the interaction that has the logic gate. Moving on, we have the NOT gate as variant 3. What this gate basically does is prevent the interaction from activating if an interaction transmits a positive signal to the type for receiver, part of the logic gate. As shown here, a positive signal is always sent first. However, the logic gate does not allow the door to open. Once I interact with this interaction again, it then sends a negative signal, which then signals the receiver for that a negative signal was received, and therefore allow the logic gate to open this door. In summary, the NOT gate enforces the requirement that a negative signal needs to be transmitted to activate the interaction. Beyond this point, we have 4 remaining variants. Unfortunately, these 4 gates are beyond my understanding, but if any of you are able to explain to us what these are and how they work, help us out in the comments. But overall, that's pretty much the basics of wiring. If you ever need help, I highly recommend checking out the Hapless Discord server, which is filled with amazing and friendly people, or check out my help server, or both. But that's pretty much it.